Okay, so here's a little bit more complicated of a reaction to figure out the full rate law. There's 3 reactants instead of like just 2 or 1. I've got 4 experiments here, so it's going to be a little bit more difficult to balance out which things stay constant and which things don't. So let's take things one at a time. I think that if I were to look at reaction 3 and reaction 1, then what do I notice? I notice that these 2 are the same and these 2 are the same. So I can figure out what the order is with respect to I if I do 3 divided by 1. So what do I get? I get 2.30 times 10 to the negative 6 divided by 1.15 times 10 to the negative 6. That equals the rate constants, K, they're going to cancel. I know that the concentration of H2O2 is 0.01 divided by 0.01. That's going to be to the A power. I'm just going to use A, B, and C because I've got 3 of them. Now I've got I. I'm going to use 0.02. That's 3 divided by 1, 0.01. That's the B power. And then H plus is 0.0005 divided by 0.0005. That's all to the C power. And so what's happening here? This one's canceling, this one's canceling, that one's canceling. And then what am I left with? I get 2 equals 2 to the Y. So Y, or excuse me, 2 to the B. And so B must equal 1. Okay, so I solved for the order with respect to iodide. And so now let's figure out what's going on with the order with respect to, it looks like H2O2. If I take a look at equation number 2 and equation number, or experiment number 1, then what stays constant? It looks like everything is constant here and here, so I'll be able to figure out hydrogen peroxide now. So let's go ahead and do that then. So it's 2 divided by 1. And so what do I get? I get 2.30 times 10 to the negative 6 divided by 1.15 times 10 to the negative 6. That equals my K's. They're going to cancel. The H2O2 is 0.02 divided by 0.01. That's to the A power. Then I is 0.01 divided by 0.01. That's going to cancel. And then H was 0.0005 divided by 0.0005. That's to the C power. That's going to cancel as well. So this one goes away, this one goes away, that goes away. I'm just left with what I need in order to solve for A. So what do I get for A? I get 2 equals 2 to the A. So A must also equal 1. Okay, looks like we're down to it. Let's take a look at what happens if I look at 4 divided by 1. So it looks like if I have 4 and I have 1, then everything is constant here and here, here and here, but this one and this one change. So that's going to allow me to sort out C. So if I go 4, I got 1.15 times 10 to the negative 6 divided by 1.15 times 10 to the negative 6. That equals K over K. What did I have for the two? For these, for this one, I had 0.01 over 0.01. That's to the A power. What did I have for I? Same concentration, 0.01 over 0.01. That was to the B power. Now it comes my H plus. It's 0.001 over 0.0005. And so what do I get there? That's to the C power. Let's take a look. This is going to cancel, this is going to cancel, and this one's going to cancel. So what am I left with? 1 equals 2 to the C. And so this is an interesting power. There is something that when I raise 2 to it, I get 1. And of course, that's 0. Anything raised to the 0 power is 1. And so now I figured out the order with respect to H plus is 0. And so it's possible for a reactant to not affect the rate. And when that happens, that means that that's a 0th order reaction with respect to that reactant. So what I'm going to do now is I'm going to figure out the rate constant. Looks like I'm going to use experiment number 1 to do that. And then I'm going to get, so let me write in my units because my units are important now. I got K times 0.01 molarity to the first power times 0.01 molarity to the first power times 0.0005 molarity to the 0 power. Remember, this all just goes to 1. And so what do I get? I get K equals 0.0115, and it's molarity over molarities times seconds. So the full rate law is equal to 0.0115 molarity to the -1 times second to the -1 times the concentration of hydrogen peroxide to the first power times the concentration of iodide to the first power times the concentration of H plus to the 0th power. And because it's to the 0th power, I won't actually include it. And so this is your full rate law. Okay.